Okay, I'm going to take the stage and continue with my presentation. So, welcome everyone to all the viewers, listeners who are currently listening to me. It's great to be here. So, thank you, JetBrains team for having me as a speaker today. So, imagine you're starting a project which you have identified as a high throughput, high performance system. You have identified that messaging shines in such a kind of architecture, and that such a project which requires high throughput and high performance and message you have identified that messaging as an architecture really shines through in such cases, and you are convinced after much research that this is the architecture that you want to follow and use in your project. And one of the first things that you have to arrive upon as a decision is the message broker or the message queue that you're going to use. You might have a set of functional as well as non-functional requirements for your project. So there might be certain features that are perfect from, say, a broker, say SQS, or something which is even better in Azure Service Bus, for example. So when you have such a situation, what is the best way to go ahead? Can we establish some baseline to think about all this? So, what are the tools that you can look into? What are the things that you might learn? What your conclusions might be? And what are the questions that you can ask yourself? These are the things I will try to touch upon in my session today. Introducing myself, I am Poornima Nayar. I'm one of the engineers and solutions architect at Particular Software, where we build N Service Bus and the entire platform around N Service Bus. I'm talking to you from Berkshire in United Kingdom. Non-work me, I'm a mother. My daughter turns 11 next month. Blimey, time flies. I read a lot. I'm also a student of Carnatic music vocals, which I've been training for over 7 years now. And if you have any questions, feel free to reach out to me on LinkedIn, X, or Blue Sky, where I am available as Poornima Nayar. So that is all about me. And I do have some code samples in my slides today, but all of that is also available as a GitHub repo, which I will share with you at the end of my session as resources. So this is a great picture, right? It's yummy, cloudy Lamingtons, and this is a picture I took myself when I was in Melbourne earlier this year, Australia. So I don't know where my viewers are tuned in from today, but we have a very grey day, very typical for this time of the year in Britain. I have my cup of coffee with me, and I would love a cake. But I cannot be eating a cake and then presenting as well at the same time. So go ahead, have your coffees and cake. But if you don't, no worries, because I have three options that I will be talking to you about today, which is Azure Service Bus and Amazon SQS, both in the cloud. And if you are in search of something more on-premise as a message broker, we'll also touch upon RabbitMQ. So what is the path I'm taking today? uh, every September we have iPhones coming out, but even when a new version of the iPhone comes out, there are variants, right? It's all iPhones, but still they have different feature sets. Some things excel in some variant and some things not so much. So similar to that, within message brokers, they all have a set of similar patterns like send receive, publish subscribe, dead letter queues or DLQs, message ordering, delivery guarantees. So we will touch upon all of these and also try to understand some of the things that you might need to watch out for, things that might be different from, say, Azure Service Bus and SQS. So I will highlight those points as I go along. And I will also try to highlight some of the standout features which I think you must and should know about. At the end of the session, I hope you have a set of keywords as well to take away so that you can continue with your research should you investigate further. So we'll start with Amazon Simple Queue Service, AWS SQS, which is a simple and reliable, fully managed queue, which requires minimal maintenance. Uh, in the sense that you provision the instance of SQS in the cloud, and from there on, managing the infrastructure itself, that will be done by AWS for you. Um, it helps with auto scaling. For example, the queue size itself in SQS is not limited. The queue is nearly unlimited in size. That's one. Secondly, if you have SQS talking to your Elastic instances, the Elastic instances itself can scale automatically based upon the message, the size of the queue itself. So depending upon the number of messages in the queue, the Elastic instances can scale out as well. But you cannot take SQS out of AWS. So consider this if you are an AWS house or if you have substantial investment in AWS as an organization. Being a cloud offering, it has integrations with a number of other AWS offerings. The one I would like to really highlight is AWS Lambda, using which you can achieve serverless distributed applications in the AWS cloud. So that's something to watch out for. More details about SQS. The message size itself in SQS can be up to 1 MB, but you can store unlimited amount of messages in the queue. If you want messages larger than 1 MB, you should bring in Amazon S3 buckets for larger message sizes. You can also batch messages while sending, receiving, or deleting. And the batch size itself should be not more than 1 MB. And there's also a limit on the number of messages that can be a single batch. That is, the number is 10. Of course, this is a cloud offering and that comes with a cost. But with SQS, the first 1 million requests a month is free. This might sound like a lot, but in reality, it is not, because every SQS action is a request. So you send, receive, delete, all of that is a request. And each 64 kilobyte chunk of data or payload is one request. So if you are looking at 1 MB of message, it is 16 requests to say read it. So that totals up to like under 70,000 messages, um, with and that's taking up a lot of that 1 million requests as well. So each, I think after the first million requests a month, every million gets charged after that. But in generally, if you have a very high throughput system, the cost can increase substantially with SQS. The feature that I want to really highlight with SQS is standard queues. This is the core feature I want to highlight today, because SQS, unlike Azure Service Bus or RabbitMQ, it's not a broker. It is a queuing service. It's queuing, and it does what it is good at. It is a screwdriver and it does the work of a screwdriver pretty well. That is how I can think about SQS when I think about SQS. So with SQS, you have very high, nearly unlimited number of API calls. The nearly unlimited gives me the vibes of nearly headless Nick, if you're into Harry Potter. But if I'm to give you numbers, you can have up to 120,000 in-flight messages. So the in-flight messages means they have been received, but they have not been processed and deleted. So they could still be in the process of getting processed before it is deleted. So it's a very high number of messages that can be on the fly, in flight at any point of time. With SQS, you have the concept of distributed queues, where each copy of a message is stored across AWS availability zones to increase durability and redundancies. And with SQS standard queues, you have best effort at ordered message delivery. The order in which the messages get into the queue need not be the order at which it gets delivered to the receivers. And SQS focuses on at least once delivery guarantee. So your messages could be delivered more than once, which means that on your receiver or the processing side, you need to ensure that whatever you do is idempotent. So you need to have idempotent receivers on your application. We'll first talk about the send and receive pattern with SQS. This is the basis of point-to-point communication. There is a sender which sends messages into the queue, and then receivers gets the messages from the queue, processes it, and moves on to the next message. There could be multiple senders sending the message, and there could be multiple receivers reading from the same queue itself, but there is inbuilt mechanism in SQS to make sure that at any given point of time, it is only a given consumer or processor that processes a given message. So that is built in, more on that later. So how does send and receive look like with SQS? We start off with an Amazon SQS client, which requires an access key and a secret and the region ID, all of which can be available from the portal for you when you set up or provision your instance. And then using the SQS client, I can use the send message async API to send the message. So it requires a queue URL and the message body. In my case, it is a serialized record that I'm using. It can be string. It can be string in plain text as well. But in real world scenarios, it is most likely to be a serialized object. On the receiving side, It is a pull operation, a long-lived pull operation that gets the messages from the queue. We start off with the SQS client and a receive message request. And using the SQS client, you can receive the messages and process them, which I'm doing in the for loop in line 10 here. So the response could contain more than one message if you are batching the messages as well. And I can loop through each of them, process it, and the final action to take is an explicit delete command back to SQS. This informs the SQS server that, hey, I have processed the message, now go ahead and delete it. Otherwise, the message will go back, become available in the queue, ready to be received again. So that is something that you need to watch out for. And with delete API, you also need a receipt handle. So this is like a unique ID or a hash, which is associated with the receive operation of the message. So with the receive operation, so you get the message and you use the receipt handle of that receive operation to go back and delete the message from the queue. You can also have message metadata as a part of sending message. So you can have structured metadata added to your message itself, and they are available as message attributes. So if you look at line 24 here, I'm adding a set of message attributes here. The message attributes also contribute to the size of the message. It's not typically like headers. You can think of it like headers, but this contributes to the size of the message itself. So you need to be mindful of that. I think there's an upper limit on the number of message attributes as well. It's limited to 10. So be careful on how you use it. One of the use cases that I have seen it being used is you receive the message and then check the message metadata, message attributes to see which handler can then handle this message for me. But be mindful of when you do that, because you are building something that is already available out there, for example, like Mediator. On the receiving side, there is a gotcha when it comes to message attributes. I lost an hour of my time thinking and wondering what is going on. The gotcha is this: you have to make sure that you explicitly specify what message attributes you want to receive. It can be all, in which I get all the attributes, or you can go for a wildcard pattern or specific message attributes to pick and choose what message attributes you want to receive. So that's one gotcha that you need to watch out for. But once that is received, I can use the message attributes in my processing if needed. So we spoke briefly about how a given consumer only can process a given message at any given point of time. That mechanism is called visibility timeout. It is available in both Azure Service Bus as well as RabbitMQ with a slightly different name, but this is kind of a repeatable pattern. So this is the duration for which a message stays hidden from other consumers after being received. The minute it has been received, a message has been received by a consumer, it is locked and invisible to other consumers. So thereby preventing the chance that it could be consumed by other consumers at any given point of time. And it is expected that even if you are processing a single message or a batch of messages, it should all be processed and deleted within that visibility timeout period. And this is also a mechanism to ensure that you do not have unhealthy receivers. And if you have unhealthy receivers, say that something has just crashed or something is unhealthy, that it is just taking ages to continue processing a message, the message doesn't get locked by receiver forever. It goes back into the queue so that a healthier receiver can then receive it and process it. So a visibility timeout can be specified at the queue level when you provision your queues or with a receive message request itself. The default is 30 seconds and you can go up to 12 hours. So in this case, I've set the visibility timeout to 40. You can also change the message visibility during like a heartbeat mechanism during processing. But even when you do that, you cannot take it up to more than 12 hours. And this could be something that is useful if you have a message that is taking long to process legitimately. And there's something that you need to bear in mind with visibility timeout, because visibility timeout, if it is too long, it can cause a delay in retries. So the message will be like locked by the receiver. And if you have a short visibility timeout, the message can end up being processed and partway it goes back, and then that loop repeats over and over again till the message dead letters. So this can have impact on the throughput of the system. So make sure you adjust the visibility timeout based on the actual time it takes to process a message. Another feature that I would highlight with long polling and short polling, which has impact on the cost as well, is this feature long polling and short polling in SQS. With short polling, you have immediate response after sampling a subset of servers. So we spoke about the distributed queues and messages spread across AWS availability zones. So with short polling, only a subset of those servers are being sampled. So which means that you can have empty response or even a false empty response if the server sampled do not have a message, but there was a message sitting in another server which was not sampled at this point of time. This means you can have a much more responsive application, but but if you have a server that still holds a message and you have a false empty response, that message will come to you at some point. But because you are reading or trying to poll the servers and get a message out, this could impact the cost which you have with SQS. With long polling, it queries all the servers, it samples all the servers and responds only when you have at least one message available. This means you have lesser responsive application, but you can reduce the empty responses as well as false empty responses and thereby reduce cost. So something for you to think about. Dead letter queues. This is another repeatable pattern that you see across Azure Service Bus and RabbitMQ. But even though the concept of dead letter queue is queues for messages that cannot be processed, the three brokers work in three different ways. The concept is similar, but there are differences, and you will understand the differences as we go through. With SQS, there's only one way that you can dead letter a message, that is exceeding maximum receive count. This is an attribute associated with a message. Every time a message is received by a receiver, not processed, the receive operation, there is an attribute called receive count, which goes up by one every time that is received. At some point, that count keeps increasing, and the maximum receive count that you specify on the queue could be exceeded, and such message will then end up in DLQ. But DLQs and SQS are not created by default. You have to create them, you have to provision them, and it needs to be managed separately from the source or the actual application queue itself. So this part is something that I'm not quite convinced about myself. So you set up a queue and say that, hey, this source queue, that is my standard queue, which I've highlighted here, uses this queue as the DLQ. And then I go to the source queue, that is my standard queue, and say that the DLQ, my standard queue, which I have specified and set up as a DLQ, is the DLQ for this queue. And I need to have the maximum receives of 5. So every time a message has hit that maximum receive count of 5 or over, it DLQs. So it needs to exceed 5. The sixth time it tries to be received, it DLQs. And once this is all set up and tied up, then you can start redriving your message to your source queue or to a custom destination. This also adds to the cost because you're trying to read and receive and delete from your DLQs. So as I said earlier, the maximum receive count is the only way you can dead letter a message in SQS. You cannot have a receiver that says, I cannot process this message. I want to dead letter it. That feature is not available. So it expects you to do the work. So make sure that you adjust that maximum receive count based on this as well, because this is also adding to your cost. And once you have your messages redriven from DLQ to the source queue, messages are mixed and the queue order is all out of place. And one thing to remember is that if you have messages that are expired, they are permanently deleted. They are not DLQ'd in SQS. There's also the concept of first in, first out queues in SQS. This is for FIFO message delivery. So the order in which the messages are queued in the queue, that will be the order at which they are delivered as well as processed. This queue is for exactly once delivery. Each message is delivered exactly once. And there is message deduplication using a deduplication ID or even content-based deduplication that you can enable in your instance. Here, the message delivery order and the processing order is maintained. Even if you have a retry, that does not disrupt the order of messages being processed. So if you have a group of related messages to be processed, that is one case you can use FIFO. But this is at the queue level itself. But again, understand that sticking to something like order delivery and order processing can impact the throughput of your system. So try to understand whether your business actually requires ordered message processing, because real world business processes are always adaptable. Things can go out of order and business runs as smooth. So try to catch those edge cases. See if you can use patterns like orchestration and choreography, for example, sagas, to actually put something as a stopgap or to catch those edge case scenarios and stay out of ordered processing. Talking about another well-known pattern behind event-driven architectures, publish, subscribe. The good news is that SQS does not have native pub/sub. For this, you need to bring in what is known as the AWS Simple Notification Service. With SNS in place, you have a service or a producer that publishes to what are known as SNS topics, and the SNS topic fans out to subscribers. Here, our subscribers are SQS queues, which you need to provision and then bring in and subscribe to the SNS topic, at which point all the messages that are published into the SNS topic will be available to all the subscribers, that is your SQS queues. So once you bring in your SQS queues after provisioning them and subscribe to the topic, the reading of data, the information from SQS queues, it's the same as what I discussed with standard queues or even FIFO queues. I'm not touching on FIFO queues because ordered processing is a completely different uh, ball game and it's for another day. But yes, everything that we spoke about queues matters once you hit this point onwards. So with SNS, the message size is up to 256 kilobyte. Again, batch size of 10 with batch size itself not exceeding 256 kilobyte. This itself is a gotcha. So if you want to bring in SQS and SNS together, SQS has 1 megabyte as the message size. This is still at 256 kilobytes. So you will want to use 256 kilobyte if you want to use event-driven architectures with SQS and SNS in place. So what are the steps involved in code? You start with an SNS client, and using a publish request, you specify the topic ARN, which is the topic ID, and the message you want to publish, and you can publish that using the SNS client. So it is very discrete APIs here, one for sending and one for publishing. So that's something to highlight here. The second step would be to provision your queue and subscribe that to your topic. So that is done using the subscribe request here. So if you look at line 10, I have an endpoint here. The endpoint is nothing but my queue, which I'm trying to subscribe to my SNS topic. And in line 13, I have the subscribe async API using which I am subscribing to the topic. So the queue is now subscribed to the topic. And once this is done, I can start receiving messages, looping through them, processing, and deleting them, just like we discussed before. One thing that you might want to watch out for with SNS and SQS coming together is the row message delivery. So if you don't have row message delivery enabled, your actual message would be deep inside a SNS payload. It would be wrapped inside an SNS payload. If you don't want this, then you might want to turn on the row message delivery. And the biggest gotcha of it all, you need to make sure that SNS has permissions explicitly granted to publish to the SQS queue. So the permissions need to be tied up. Otherwise, you'll be like me, wasting an hour behind this again. So this is one of the biggest gotchas with SQS and SNS working together. So where can you use SQS? What would be the good use cases for SQS? If you have low maintenance queuing, if you want high availability and massive scalability, if you like the SQS SNS loose coupling model and you're okay to work with it, if you have native AWS integration already, if you're a AWS house primarily, all these are good go-to signs for using SQS. And if you need fine-grained routing or custom protocols, all of which needs a much more advanced broker, maybe SQS is not suited for it. Do not try to, reuse the attributes and then have your own routing in place. Go for a proper message broker in such instances. If you want hybrid development or very high throughput, maybe try consider staying away from SQS. And that brings me to Azure Service Bus, which is my favorite broker because it says it does what it says on the tin. And I am reminded of a Swiss Army knife when I think about Azure Service Bus. It's quite versatile, it's quite powerful, and when I look at the docs, it's quite clear, and I can understand a lot of things pretty quickly as well. Azure Service Bus is a fully managed enterprise message broker. Again, it's a PaaS offering in Azure alone. You cannot take Azure Service Bus outside Azure. I want to highlight some of the integrations with other Azure services here. Just like SQS uses Lambda to achieve serverless applications in the cloud, here we have Azure Functions to achieve serverless applications in the cloud with Azure Service Bus. You also have a good local development experience now with Azure Service Bus Emulator, which is more of a recent addition. I think it came out earlier this year. We also have the community tool Service Bus Explorer if you want to administer messaging entities. Talking about the cost, I just want to put some numbers in front of you. So I've come up with a rough cost that I've calculated, which is standard tier, which is recommended for development usage. It can count to approximately $10 a month, and it's just a shared capacity. While as premium tier, which is what you should consider and you must use for a production workload, it can come up to about $700 per messaging unit per month. And your messaging unit is your dedicated capacity. And from some of the talks that I've seen about Azure Service Bus, I understand that the standard tier uses SQL Azure for persistence, premium tier uses something else. I don't know what that something else, but hey, that's some key information I thought it's good to share. Message sizes, standard tier permits messages up to 256 kilobyte, and in the premium tier, you can go up to 100 megabyte. But the queue itself is limited in size. It can be up to 5 gigabyte, after which message rejections can happen. With Azure Service Bus, of course, you can have batching in place. There is no upper limit on the number of messages in the batch, but batch sizes in standard tier is 256 kilobyte and premium tier is 1 megabyte. We spoke about the queue size being 5 gigabyte, but you can increase that to up to 80 gigabyte if you use partitioning. But be mindful of the cost that comes with partitioning. Although it can improve the message throughput and availability and resiliency, it can substantially increase the cost that you have with Azure Service Bus. Again, this is quite a deep dive topic, which I don't want to cover today, but I want to leave you with the keywords in case you want to go and research about it. There's a very good article about partitioning in the documentation. Make sure you research well about it. Send and receive, the pattern itself is not as different as it is from SQS, but the thing I want to highlight here is the two different modes that you have with Azure Service Bus. The first mode is receive and delete mode, which is a destructive read mode, where you have messages that are marked as consumed and then sent to the consumer. And this focuses on at most once delivery because the messages are already marked as yes, it's been processed and consumed, and then sent to the consumer. So each message is delivered only maximum once. So use this if you can actually cope up with the message loss. For example, after sending the message, between the send and then it being received by the receiver, something could happen, something could go wrong, and then that message is lost. Midway processing of the message, the processor could crash. So again, the message is lost. So if you are okay with messages being lost, if it is a system that can tolerate message loss, then you can use this mode. But otherwise, peak lock mode or the non-destructive read is actually recommended. Here, the message is locked and sent to the consumer. The consumer must process and issue a complete command to the broker within what is known as the peak lock timeout, which is the parallel concept of visibility timeout in SQS. This mode focuses on at least once delivery, which means that each message can be delivered more than once. So again, think of idempotent receivers. So how does send and receive look like in peak-lock mode? You start with what is known as a service bus sender. And then using the send message async API, I send a message, which is a service bus message, which can contain a serialized object as well. And on the receiving side, messages are pushed to the receivers from the broker. So I started with creating a service bus processor, which has handlers to process message as well as to process any errors. And once I'm inside the message handler, once the message has been received, you can run a handler to process the message and issue the complete command that is in line 29 to notify the broker that this message is completed processing. You can delete that off from the queue. So this is a push mechanism when it comes to messages getting to the receiver, while as with SQS is a long-lived pull mechanism. You can also have metadata added to the message, and it follows a concept called application properties in Azure Service Bus. Of course, it adds to the size of the message, but it does not require additional processing on the receiver side to get that as a part of your message. It is available to you as a part of your message. You don't need to explicitly specify that you need to receive it. See, for example, I have received the message here and I'm processing it. I don't need to do any extra step or any extra computing to receive those. Publish Subscribe is natively supported in Azure Service Bus, and this is one of the reasons it is different from SQS, which is a simple queuing system, whereas this is a more of an advanced pattern which is supported by a broker. So with Azure Service Bus, you can have a sender sending or publishing messages into a topic, and then in comes your subscriptions with subscribers, which can receive the messages published into the topic. The default is a fan out where each subscription gets everything, every message published into the topic, and then you can process it. So each receiver gets a copy. Now, the starking difference here is that with SQS, your subscriptions are basically queues which you have to provision and then you have to subscribe as well. So it's a two-step process. Whereas in Azure Service Bus, you set up a subscription in your code, and that sets up the virtual queues for you behind the scenes. You don't need to manage those queues explicitly. That's all done for you by the platform itself. However, you need to understand that there is a maximum of 2,000 subscriptions that is permitted for each topic. So if you have larger fan outs, you need to implement order forwarding by configuring second level or third level topics as well. So we spoke about the fan out, which makes sure that each subscription gets a copy of the message. You can also be selective about the messages that you want to receive. This is a pattern that we have in SNS. I did not cover it there, but understand that message topic filters exist in SNS. But this is more of an advanced concept in Azure Service Bus. There's more feature set to it, because what you can do is have subscription rules to have subset of messages. And in subscription rules, how am I doing for time? Okay. Okay, with subscription rules, you have filters to select messages and actions if you want to further annotate that messages as well. And each subscription, when you go in with a subscription to the topic, it can have multiple rules in place as well. There are three different types of filters itself in place. The first one being SQL filters. So you can have a SQL-like expression evaluated against the system property of the messages or even the user-defined application properties of the message and select only such messages which match. You have Boolean filters, the true filter or the false filter. The true filter is the default one, which selects all the messages. Then you have the correlation filters, where it is a set of conditions matched against system and user-defined properties. And this is a case-sensitive string comparison. So one difference between topic filters in SNS and Azure Service Bus subscription filters is that with SNS topic filters, you can evaluate filtering and evaluate that against the message body. But with Azure Service Bus, filtering is only based on the message properties, that is the application properties or the system properties. It cannot be evaluated against message body. So if I want to show you all of these concepts in a single go, I have a publisher which publishes to the topic, and in comes my three subscriptions. in my first subscription, it is a Boolean filter which has no actions attached to it, so no annotations. So everything gets pulled in from the topic. In the second subscription, I'm using a SQL filter to filter out messages and only select those messages which has a property called color equals, and the color should be red. In my third subscription, I'm using a correlation filter, and I'm using a filter uh, on the subject of the message. So I'm filtering out and selecting only those messages with the subject blue. And while I do that, I am also showing you a demo of what an action can be to annotate a message. So let's have a look at the code quickly. On the sending side, when I sent my message, it is again a service bus. I am adding a subject called chosen color. Subject is a system defined property of the message here. And the chosen color is a random color that I've chosen from red, blue, and green. I'm also adding that chosen color as an application property for the message, and I am sending that message. So notice here that even if you are publishing to a topic here, the API that I'm using is send. So SQS was send and publish, which was different APIs. Here, sending is also sending. Sending to a topic is which is publishing with the pub sub pattern. That is also sending in this case. On the receiving side, it is the first subscription that I try to add. It is the Boolean true filter. Just to show you how you can add it, I am first deleting it and then adding the true rule filter in place. In my second subscription, as I told you, here I'm creating the subscription and then having a rule in place, which is called a red SQL rule. And the filter I am attaching to it is that I want a new SQL rule filter which selects all messages with color red as in the message properties. And the last one, I'm going for a correlation rule, whereby I'm using a correlation rule filter, which says I want to select all messages with the subject blue, and I want to act upon it. I want to annotate it, and by adding another property called action set up. So this adds another property to the message itself. And once the subscriptions are in place, I start receiving the messages according to the rule that I have set up. So in the first case, if the rule name selected is 0, I get all the messages in the receiver. Here, if the receiver selects rule number 1, then I get all messages that are red. And in rule 2, I only get messages that are of subject blue. So this code is in the repo. Have try setting up an Azure Service Bus instance in the cloud and try running the code against it. You would be able to see how messages are selectively pulled into the subscription as a part of this rule. So correlation filter is better to use over SQL filters because it's more efficient at processing and has less impact on throughput. With dead letter queues, the first difference to understand here is that DL queues are created automatically and it doesn't need separate management from the source queue itself. And the DL queue for any queue can be accessed at /dead letter queue. So if you have a Azure Service Bus instance or a system with 100 different queues, then you will have 100 different DL queues in place as well, which can be quite a nightmare to manage as well. So think about that when you design your system. So how can messages hit the dead letter queues in Azure Service Bus? So if it exceeds maximum delivery count, so just like we have receive count and max receive count in SQS, we have delivery count and max delivery count. Every time the delivery count exceeds the max delivery count for a message, the message is automatically dead lettered. If you have an expired message, you can dead letter it. It is something that you need to enable on a queue level. If you have errors in processing subscription rule, then a message can dead letter. If you have auto forwarding scenario with chaining topics for large fan outs, make sure that the message does not go over 4 hops. If it goes over the 4 hops, then you have messages that will go into dead letter queues. And the final big thing is that you can also have application level dead lettering. A receiver can say, I do not want to process this message. So, hey, we can have some lazy receivers or even clever receivers from the perspective that you think about. If a receiver can kind of understand that the message is corrupt, yeah, it can totally dead letter it rather than going through that work a number of times. So some overlap with the SQS FIFO-Q is what is known as message sessions in Azure Service Bus. Sometimes you might want to make sure that you have a set of related messages that needs to be processed in that correct order. That is where message sessions come in. So with SQS FIFO-Qs, that is something at the queue level itself, but this is something that the application can control to certain instance because the ordered processing is only at the session level. And what does it mean by that? So in this figure here, I have a sender that keeps publishing or sending messages into the queue. I have three different sessions here, A, B, and C. And A is peach colored session, B is green colored session, and C is purple colored session. So these three sessions denote three ports of messages. And all those messages in that port should be processed in a specific order. So what happens on the receiver side is when the receiver understands that, hey, this is a new port of message, this is a new session, I have not seen this session before, it locks itself to that session and then starts to process the message from that session itself. So all the messages that then coming from the sender related to this specific session will only go into the specific receiver. So in this case, it is receiver A who might get hold of the session A first. So all the messages in session A will go to the receiver A, receiver one, which processes the session A, and it will be processed in that specific order. Similar thing with session B and session C as well. Now, how does it understand that this is a session that the receiver has not seen before? So that we can understand from the code here. So if you look at the code here, while I'm trying to send a message, I'm also adding something called as a session ID here. This is an application generated unique ID. So if I have a set of messages, say a set of messages pertaining to a specific order ID, the order ID could be that session ID to say that, hey, this is a session ID, everything from here must be processed in order. And on the receiving, okay, one more thing. Azure Service Bus has no clue of understanding when the last message has hit from the session. So it is your duty in the application to make sure that there's some kind of a pointer so that we can have that information at the receiving end that this is the last message of the session. After that, I can release the session. So on the receiving side, while I have received my message, the thing to do is check whether it is the last message in the session based on the application property. And if it is the last message in the session, set the session state to null and release the session. You must also understand that sessions are relatively computationally expensive because this is all about setting uh, virtual queues in the background. So it is quite expensive computationally. Again, understand and see whether you can bring in patterns like Saga for workflows and handle edge case scenarios and do what you need to do if things arrive out of order. So that is about sessions. Azure Service Bus is a transactional broker, which means that you can group one or two, so two or more operations into an execution scope and make sure that those operations are atomic. They succeed as a whole group or they fail as a whole group. There is no scenario in which I can send one message and then send a second message, and between that, if you have a failure in the broker, then things are out of place and we have a kind of disturbed system which is not consistent enough. And there are various different operations that can be performed in the transaction scope, like send, complete, abandon, letter, defer, and renew lock. Receive is assumed to be under peak lock, so it is not a part of things which can be performed, operations which can be performed in the transaction scope, and that is why it is not made into the list here. Looking at the code samples, what can we say? So here I have in line 5 and line 11, I am sending two different messages into the broker. Now, in between each or after each send operation, if I try to understand the number of messages in the broker queue, I can see that every time I send my message, the queue is incremented by one in size. The number of messages increases by one. So this is a scenario where you don't have transaction enabled. But with transaction scope enabled, if I try to send messages and then try to understand the number of messages after each send operation, you can see that I have also got a screenshot of what the result is like. At each point of this console.write lines, that is line 7 and line 13, the number of messages in the queue is 0. It is after transaction complete, if I try to get the number of messages in the queue, that is, I can actually see that messages actually committed into the queue. One thing to notice here is that the business data that you have is not included as a part of transaction. For that, you need to consider outbox pattern. So with that in mind, some of the use cases where could Azure Service Bus be a good candidate? If you have enterprise grade cloud native messaging, if you have advanced filtering scenarios, if you are an Azure house, if you need transactionality, if you are into enterprise SLAs, you need that 5 nines or 4 nines and a 5. That is where Azure Service Bus can be a good candidate for your use. But if you have very simple message requirements, or if you have real time requirements, if you have extreme high throughput needs, again, for hybrid development, Azure Service Bus is not a great candidate for that. And that brings me to the last broker. Let's go through this very quickly because I've got about 15 minutes to me. RabbitMQ. So this is an extremely powerful and versatile tool. Think of Swiss Army knife, which a sledgehammer as well as a jacksaw on top of it. But hey, when you have that kind of a power with a tool, you need to be careful as well. And that is exactly the advice I would give you if you're looking into RabbitMQ. This is not a system for the faint-hearted, and this is where even I had a huge learning curve to myself because there's the broker aspect of it, the features of that, and there is RabbitMQ management, which again is a area which needs a lot of investment and research and knowledge before you can get started on a journey with RabbitMQ. So if you're looking at RabbitMQ, make sure that you understand the ins and outs of RabbitMQ management as well if you are considering RabbitMQ for an on-premise option. RabbitMQ is an open source message broker with commercial offerings available. Um, sorry. It supports multiple protocols, AMQP, MQTT, and Storm. So if you have IoT requirements, IoT projects, I've seen RabbitMQ being used there. In fact, my colleague Ramon, he is a firefighter in Netherlands as well. He volunteers to be a firefighter. He has a system which he has built using messaging in his house to make sure that he gets all his alerts on time so that he can be out on his car to the fire station within seconds of receiving the alert. And he explained to me that he uses RabbitMQ and MQTT underneath the hood to help him with his messaging system. Um, it focuses on at least once delivery guarantee, and we have active community support. With RabbitMQ, you can deploy it on premises or even run it in the cloud. And if you want a local development experience, you can run RabbitMQ in Docker, or if you want to host it in Kubernetes, that is also absolutely possible. A word about RabbitMQ management: understand and make sure that you have the sufficient knowledge and skill set in house if you want to look into RabbitMQ as a broker for your system. So I don't want to talk much more about this, but there's things to understand like clustering to support high availability and distribution of the load. All that needs to be understood and carefully studied before you go down the path with RabbitMQ. RabbitMQ also follows a plugin-based architecture where you can bring in different plugins to extend the core broker functionality. And some of the things that I want to highlight is the RabbitMQ Web UI for management and for monitoring, the Shovel plugin for Q2Q message transfer, which can be also used to redrive messages from one queue to another. If you want delayed message or delayed message support or scheduled message support, that is a feature, that is a native feature in Azure Service Bus as well as SQS. This needs a plugin here. And there are other plugins, not just limited to this, for tracing, authentication, Prometheus, RabbitMQ metrics, and so on. There are many, many different options, but these stood out to me. So I'm just listing it here. With RabbitMQ, you need to be mindful of the queue size because it is limited by the server disk capacity. So make sure that you have sufficient alerts in place. Otherwise, it can lead to message loss. And while RabbitMQ is all about arbitrary message sizes, please do not go into large messages with RabbitMQ. Bring in a pattern like database and claim check to make sure that you have sufficiently small message sizes, but still you can make use of the large message support using the claim check pattern or the database. With send and receive, again, we have the send and receive, which is sending and receiving. But there are things that I want to highlight here. Again, two different modes, which is very different from the destructive and non-destructive read, which is round robin to begin with. The first mode is round robin, where messages are delivered to the next consumer in sequence. And this is regardless of whether that consumer is ready to process it or not. So the consumer might be quite busy, but that is not taken care of in this instance. It RabbitMQ just pushes the message onto the consumer. So messages go sequentially and it is given out in a kind of distributed, even manner. The other one is fair dispatch, where messages are delivered taking into consideration the consumer's current load. So new messages always go to customers with or consumers with fewer acknowledged messages. So if I have one acknowledged message, for example, I might not receive a message at all for consuming. So this ensures that workers only receive new messages when they are ready to process them. But use this very, very moderately considering your requirements because this can have a throughput impact. Now, how about we look at some code here as well? So we start off with declaring a channel and declaring a queue here. So there are things like durable queue and auto delete queue, which we will touch upon in a minute, but understand that those facilities are here. So channel is like a virtual connection to your broker. So you have applications that establish a single connection and then multiplex channels in a single connection. And once your channel and your queue are in place, I can use the publish async API to actually send a message. So this is again certain differences in API, but I think it makes sense and I will explain to you why. But even with sending, we are actually publishing a message into RabbitMQ. So on the receiving end, this is again a push operation from the broker to the receiver. There is an event handler in place called the received async, which I can use to process the message. The the main thing I want to highlight here is the basic ACK, which is an acknowledgement sent back to the broker saying that I have processed the message and I want to make sure that this is taken off your queue. This is all good to go. So similar functionalities, similar patterns that you see here. Um, so this is how a round robin would look like. So I have a couple of messages that are being sent from the processor here. If you can see these two windows here, you can see that the messages are evenly distributed. Doesn't mean it is getting processed kind of evenly. It is just sent evenly. On the fair dispatch mode, that happens on the receiver side. It is a set of settings on the receiver side that controls it. So the big difference is in this line of code, the basic pose async, where it sets the prefetch count to 1. So this prefetch count limits the number of unacknowledged deliveries. So when there is when this number of unacknowledged deliveries has reached this prefetch count that has been set here, RabbitMQ stops sending messages to that consumer. So if you ask me, the prefetch count of 1 is pretty conservative because at this point, till I have processed this message that I'm processing and send back the acknowledgement, I'm not getting any messages as such. So which means that you could have a busy system and then your throughput could suffer. Another thing that I want to highlight here is the way I am trying to simulate that busyness of the receiver is by adding, uh, introducing a delay. So basically, I have a message in the message with a number that I'm sending from the from the sender. So based upon that number in the message, I'm introducing a task dot delay, that many seconds of delay. So if you run this with a Docker instance of RabbitMQ, you can again see this in action. I want to also highlight the basic ACK async, sorry, the auto ACK here. So there is a functionality where you can actually say auto ACK, which is similar to the destructive read in Azure Service Bus, but it is recommended to use the acknowledgement that the code itself, the processor itself gives the broker. So if you want to quickly see the fair dispatch in action, if you look at the window here, you might be able to see that the messages are not evenly distributed. It is distributed on the basis of which consumer is less busy and is more likely to process those messages. So talking about publish subscribe. So here I need to introduce the concept of exchanges and bindings. With RabbitMQ, you never send a message into the queue. You never interact with the queue. We always publish messages into exchanges, and that is why we have the basic publish async API or not a send API. The send operation there worked because when you do not specify an exchange, the RabbitMQ default exchange kicks in and all the messages gets published into that exchange. So that is the reason why API is published, and it actually makes sense as well. So basically, exchanges are your routing table, but having a routing table alone wouldn't do because we also need routing rules, and that is what is called a binding. And binding establishes the relationship between exchange and queue. So you have exchanges and you have queues and entities, and it is the binding that establishes, yes, this queue is bound to this exchange, and that is where subscriptions comes in. So it is subscriptions, it is publish subscribe, but it is a very different perspective to look at it. And how is routing logic implemented? So it can be based on the type of exchange as well as routing keys. So we'll touch upon the four different types of exchanges very briefly. So the first one is fan out exchange, where you bind a queue into your exchange and all such bound queues get a copy of the message. Here I declare an exchange called logs and publish to the exchange. So again, it is publishing. And on the receiving side, I bind my queue to that exchange. Also note that when I declared the exchange here, it is a fan out exchange. That is a very important thing. And the name of the exchange should also be exact when you try and bind your exchange, bind your queue to the exchange. From there on, it is business as usual. You receive the message and process it and then act back to the broker. You can also have direct exchange if you want to selectively be selective about the messages that you receive into your queues, that is subscriptions. Here you have producers publishing to the exchange, and when they do that publishing, there is something called a routing key attached to the message itself. When queues are bound to the exchange, of course they need to specify which exchange they are binding to, but they also want to specify, you also have to specify which routing key they must use to bind to the exchange. And from there on, only those messages which have a match between the routing key and the the queues that use that routing key for binding, those would be selected in. So on the sending side, I'm declaring an exchange called direct exchange and then publishing messages into that exchange. Understand, note that there's a routing key in place here, which is a random number chosen between 0 and 3. Sorry, not 0 and 3. It is one of the items from info, warning, and error that I'm selecting from and using as a routing key. On the receiving end, when I bind my queues to the exchange, I am specifying the routing key. So in this case, only messages with the routing key info and warning are selected in to the subscription or are available to the receiver for processing. There's also topic exchange, which takes the routing key up a level because instead of having an exact match on the routing key, you can also have wildcard patterns in place. So you have 2 or 3 words delimited by the period, the full stop, and you can have patterns. So hash is for matching 0 or more words, and star is for substituting for 1 word. So in the first example, if you have hash dot error, anything that has dot error as the routing key will get selected. And in if it is a star dot info, it should have something like log1.info or application1.info, that exact 1 word match which would get. So the star will be replaced by exactly by 1 word, and all those messages would be selected in. With headers exchange, messages are selected based on the message header attributes. There's also the concept of dead letter queues, where you can have a message as dead lettering if it exceeds the delivery limit. Again, a very similar concept that we have seen in Azure Service Bus and SQS. If you have message expiry, then that goes into dead letter queues. If a consumer rejects the message, that also can dead letter. And if messages get dropped when a queue length is exceeded, then that also can result in a message dead lettering. I also want to touch upon the queue types in RabbitMQ today because that is one of the key concepts. There are 2 different types of queues in RabbitMQ. One is the classic queues, which was the original queues in RabbitMQ. This has optional replication. It has optional persistence because it can have in-memory persistence as well as disk persistence. If you don't have disk persistence, what happens is that if the broker restarts, the messages would be lost. But this has high throughput. But what you should consider in, or what is recommended for production usage, is quorum queues. It has built-in raft replication using the raft consistent algorithm. It is always persistent. It is highly durable. It has maybe slightly lower throughput compared to classic queues. But if you have data safety as a primary concern, please use quorum queues. In fact, that's one of the standout features of RabbitMQ. If you go through the documentation of RabbitMQ, you can understand that data safety that is of very prime importance as far as RabbitMQ is concerned. Here's a little comparison of the features of the classic and quorum queues. The most important thing is the poison message handling here. So we saw about how if a message exceeds the delivery count, it can dead letter. That feature is available only in quorum queues, and that's not something the classic queues can do. Again, another feature is the persistence of message. If you're using classic queues, the queue has to be marked persistence. That is where you have the durable queue and auto delete set to false. But the message itself has to be specifically marked persistence in such instances. So if you go into the code, if I highlighted basic properties of persistent being true, I can bring that back on screen after my session. But that is what specifying the per message persistence of the message with classic queues. With quorum queues, messages are always persisted. The other thing I want to highlight here is consumer exclusivity. That is making sure that only a specific consumer consumes from a specific queue, and that will be the only one to consume it. That is available only for classic queues, but when it comes to quorum queues, you can achieve that with single active consumer, which is a concept where you have that single consumer consuming from the queue at any given point of time, but there is a backup in place. With consumer exclusivity, if the connection between the consumer and the broker drops, the consumer has to reconnect. But with single active consumer, it kind of graciously shifts over to the backup consumer that is available in place. It will still be a single consumer consuming it, but there is a graceful transfer of consumption to the other registered consumer. Um, of course, RabbitMQ has some transactional features in place as well. There is transactions whereby you can support atomic transactions, but it is less performant, but it is highly consistent and is recommended for critical operations. But what RabbitMQ does seem to be recommending is publisher confirms, where the producer of the message or the sender of the message can get an acknowledgement from the broker for every message that is sent. It is more performant compared to transactions, but it is lesser, weaker ACK-based consistency. But if you have high throughput apps, then this is a good choice. And when is RabbitMQ a good choice? If you have complex routing requirements, on-premise deployment with full control, support for multiple protocols, if you have open source requirements, real-time applications, if you want multi-cloud portability, all of these are good use cases for RabbitMQ. But if you don't want to manage infrastructure or automatic scaling, or if you have the requirement of 5 nines as an SLA without managing the infrastructure, these are all scenarios in which you should reconsider your option. If your team has no operational experience, again, reconsider the option, because RabbitMQ management is no easy task. Now, I have given you a lot of information today. Can you draw some baseline on it and come up with a set of questions that you can ask yourself, so that if you have a fourth broker that you're looking into, what are the things that you could ask? What patterns do you need to support? What is your average message size? What is your support for complex routing requirements? Are you a AWS house, Azure house, or do you have an operations team? What about your message delivery order, the delivery guarantees? What about transactionality of your data, the high message throughput information, the cloud native support? Two, what is the local development experience that you need? These are all the questions that you can ask yourself to extend this knowledge into a fourth broker, for example. But having said that, you will quickly understand once you get on this path that choosing your message broker is literally a tip of the iceberg. You haven't really started developing your message, and there's still a long way to go. Why do I say that? Because to have a good distributed system in place, which is maintainable, scalable, and offers all the values of messaging architecture like resiliency, fault tolerance, scalability, you need to invest in other patterns as well, like message routing, workflow, transactions, claim check patterns, serialization, to tests that can verify all the edge cases. So for production purposes, always consider using a messaging middleware like an Service Bus or Mass Transit or Brighter or Wolverine or Rebus. So many options out there. Go for one of these options together with the broker of your choice. Let these messaging middlewares handle the nitty gritty details of all those patterns for you while you focus on adding business value. So that is it from me today. Thank you for having me as a speaker, and thank you for tuning into listening to this session from me. And this is all the resources from me for the day. So it is, I can put it on chat. So it is bit.ly.message queue compare. If I can copy this, that is, oh God. Hold on. That is the resources. I can bring it up on screen again. In my resources is like a comparison chart that you will find, and also the GitHub repo, which has all the code examples for the day.
Thank you very much for that. I'm sorry, I'm just pasting that into the YouTube chat, and I pasted the wrong link. So 1 second. I'll paste the in a second once we finish chatting there. Thank you very much for your session. That was a great in-depth comparison of the different available there.
Thank you.
I particularly liked your description of RabbitMQ, not for the faint of heart. It was what was it? A Swiss hammer with a sledgehammer attached or something.
Yeah, there's so much in RabbitMQ. Like, I just feel that I don't know, like, even the tip of the iceberg when it comes to RabbitMQ. That's so. For example, this is all the notes that I've collated about the message brokers.
Wow.
There's tons. Like, I feel like really kind of really tiny when compared to RabbitMQ, because there's this whole concept of the broker features itself, and then there's this whole thing about management. which is like, okay, this is something different. And I haven't even covered the streaming capabilities of RabbitMQ. That's a totally different ball game in itself. So, yes, bring it on. Lots
Y-
more knowledge.
Yeah, there's lots of people in the chat agreeing with you as well about RabbitMQ. It's, but I think lots of people like it as well, so that's a good thing.
Yes,
I
it
was
is
also
open
really,
source. It is
Mhm,
actually one of the most popular transports within Service Bus as well. And if you
right.
look at libraries like Brighter or Mass Transit, everyone is supporting it because it's a broker that has definitely matured over the years.
hmm It's great. I was also intrigued with your you say your friend was a firefighter and using RabbitMQ for that. Is that like a home built solution to,
Yes,
I've got a
because I only know like the tip of the iceberg, but
mm,
I keep telling Ramon, this is a talk. This needs to go out in public as a talk. Come talk about it because he needs to be out of the door in like seconds. He doesn't have time to waste because it's a fire that he's fighting. So he has got all set of things in place that he gets his alert on his phone, and then there is all sort of messaging in place to make sure that he's out of the door
that's
in
fantastic.
yeah,
And is it something he built himself?
yes.
Yeah,
I
it's
can't talk much about it because
no,
I don't
sorry,
know too
I'm
much
just
about it, but he did say that he's using MQTT.
uh
He's using that with IoT. Yes.
No, I just agree with you that this is something that should be talked about inside. These kinds of solutions that people can build for themselves are, really, really interesting. Especially if it's just for your own use and not just for something you're building for work. Anyway, we've got a question from chat, which I'd like to ask you. Oh no, I can't find it. Sasha, do you know where it is?
Yeah, no, I have it right here. Do you think the difference between providers result in vendor lock-in, or can you abstract most differences into swappable adapters?
Yes. So if you use a messaging middleware like in Service Bus or Mass Transit, these messaging middlewares comes with that layer of abstraction. So which means that you can actually replace your broker without having much of a vendor lock-in or a code lock-in as well. So if you go with
Mhm.
native SDKs, if you are changing from RabbitMQ to Azure Service Bus, for example, that can involve not only infrastructure change, but a substantial code change as well. And that's not easy. You have too many moving parts, and that's how distributed systems are, right? Like,
Mhm.
so if you bring in something like messaging middleware, one of the messaging middleware that I spoke about, it unifies the APIs for you. It's a single API that the developers have to learn and deal with, whereas the underlying infrastructure could be RabbitMQ or Azure Service Bus. So you're reducing the number of moving parts effectively with it.
Yeah, I
Mhm.
was wondering while you were discussing the different pieces there, whether um, the different ways that the different queues work would actually change the approach you'd take to development as well. Not only the SDK, but if you built to one, could you then easily move over to another one, or is it like, throw it all away and start again?
No, it wouldn't be throw it all and start all over again for sure.
It's good
And
to
that
hear.
is that is one thing I think even my CEO Udi Dahan speaks about in his ADSD course. Think about ways you can evolve the system without avoiding that big rewrite in
Yep.
place because
Yeah, yeah.
if you think about event driven architectures, that is one of the features. You can go from a monolith and break it chunk by chunk and go ahead. But again, if you think about it from another angle, once you have once you decided to go with Azure Service Bus, that is a considerable investment that you're making upfront to understand the system, the broker itself, making sure that your functional as well as non-functional requirements are on par. There are compromises, and those are meaningful compromises that you're making to achieve the benefits that you want to achieve. So when you think from that angle, it is a substantial investment in itself. And usually people stay on that course for a long, long period of time. But what I have seen is if you are starting with messaging architecture as a complete beginner on that journey, people tend to start with the SQL as a queuing system. So that's something that I didn't speak about today, but usually what we have seen is that when organizations are not quite sure about messaging as an architecture, They start off with database SQS because SQL or say PostgreSQL could be an offering that they already have. They can
Mhm.
start using that. And then they move on to say SQS or RabbitMQ or Azure Service Bus, for instance. That is where you can really make use of one of these messaging libraries. You can have the same set of APIs to play around with. You don't need to make business level changes, code changes, maybe a little bit of config changes and redeploy as opposed to a big rewrite.
Mhm.
Does that effectively answer the question?
Yeah, absolutely. Yeah, it's great. Thank you. And just to wrap things up, I think last question then is you've given us sort of three options there. You've dived in three there. Which is your favorite? I think we can say
Azure
which one is
Service
your
Bus.
least favorite.
I wouldn't say least favorite. It's just that I see RabbitMQ as a challenge to myself. I want to understand more about it, but that is me personally.
Mhm.
I just refuse to bow down to a good challenge. I want to know more about it.
You,
So
you want to
maybe,
go down that rabbit hole?
yes, go down the rabbit hole. Yes,
I'm
I want
sorry.
to
I can
understand.
leave right now. It's terrible.
No, uh, like as of now, Azure Service Bus because it just does what it says on the tin. For me, it
Hmm.
was a lot. For me as a developer, there was documentation and the community support out there to understand the system better.
Hmm.
With SQS, I figured out that the .NET support for SQS is not quite out there. I feel Azure AWS SQS is more lean towards Java side than the .NET side. But yeah, Azure Service Bus is my favorite.
There
So
we
when
go.
I think about I try to think about queues and brokers in terms of Marvel, Avengers, those characters as well. So I was thinking,
Okay.
SQS, it's like the Captain America, very solid, does what it says on the tin. Yeah,
And
so it's
everyone loves
very.
Captain America. It has to be
Yes,
said.
Rabbit and Q was Tony Stark. Oh my God, that is a lot of responsibility on a person. It's a
Well,
lot of power, a lot of responsibility, and
that's no, a lot of power and a lot of responsibility. That's a different character entirely. That's fine
totally.
about.
And Azure Service Bus reminds me of the Master of Sorcery, that is Doctor Strange. Well, I might be a little bit biased as well because Doctor Strange, Benedict Cumberbatch is from UK as well, great actor. But yes, I am
Yes,
reminded
yes.
of Doctor Strange.
Fantastic. That is actually now the best analogy I've heard
Oh,
for a while.
great.
So I
I
think we're
hope
going
that
ahead.
sticks with the viewers now.
I think it will. Yes, I think we'll remember that one. Thank you very much for your session. It's very, very interesting,
Thank
and
you, Poornima.
we've put your resources in the chat,
Yes.
and we will hopefully speak to you sometime soon.
Yes,
Thank you very
thank
much.
you very much.